Okay, so we are looking at quantitative method, and in particular, we are looking at the normal distribution. This normal distribution is a type of probability that actually we consider, and this probability is very, very important. But we are looking at the normal distribution probability. We have to look at the features of normal distribution. So under the features, we look at feature number one. So the features of normal distribution, the first one is that it is bell-shaped. So bell-shaped is feature number one. Bell-shaped and symmetrical. Okay, so that is the feature number one. Okay, so bell-shaped and symmetrical. Then the area under the shape equals to 1. Okay, so that is another feature there. Bell-shaped and symmetrical. Okay, so this is about the first aspect that we go for. Area under the shape equals to 1. So area under shape is equal to 1. So we have the 0.5 on this one, and the other end here 0.5. In such a manner that the area is 0.5, then plus 0.5, which equals to 1. Excuse me. So that is it. The second composition here. Then the other one here, we just look at having the range of values from -3 to +3. That's the ranges of values from -3 to +3 for this bell-shaped component. So we have that. Okay, -3 to +3. Then the other thing is that it has the Z value where it corresponds to X minus mu over standard deviation. This is the formula that we use. Of course, the standard deviation is given and the mean for normal distribution. So for this one, we use the normal tables. We use the standard normal tables. This is it, what we use. Okay. So this is about this kind of normal distribution. Okay, so these are the features of normal distribution that we actually should consider. Okay, so we also now look at the other component or the other feature of this distribution, where we use on this one we use the standard normal tables. So the other feature is that we use the normal tables. Okay, so this is about what goes on. So we have the ranges that are from -3 to +3. Okay, so this is about what we have. So concerning this kind of topic in a quantitative method, very, very important kind of topic. And then also we can now look at the question under this one. So on this question here, we get to this kind of question. Okay. So for the normal distribution, of course, there are also other probabilities where we look at the conditional probability and other probabilities that we actually consider. Okay, so this is on the features of a normal distribution that we've looked at, but of course, we can also look at the probability that are conditional, where we look at probability of A/B, A given B. So this is equal to probability of A intersection B, then over probability of B. So this is what we call conditional probability. So this probability is conditional. Then your probability of B given A is actually going to be probability of B intersection A or probability of A. So this is about probabilities that are conditional that we actually also consider. Okay, so we can pick it up from the conditional one, and then we go into the normal distribution. So if you look at this question here, okay, we may have this question on this problem here. Okay, so we have the day is overdue, so we have this question where it says refer to the data set below. The number of customers who have overdue accounts according to credit card type and the number of days the account is overdue. The days overdue and the standard we have that. So less than 30, we have okay, so the number of customers who have overdue accounts according to credit card type and the number of days the account is overdue. We have the days overdue, the standard. Then you have for those, we have the one for gold, the platinum, and the total. So here, what is the probability that a randomly selected account 30 to 60 days overdue is a gold card? So you have to go for this range. 30 to 60. So 30 to 60 is here. Okay, so it's a gold. So it's a gold card. So it's a probability of gold, a probability of a gold, and this interval of 31 to 60 over probability of, okay, so this is a conditional probability. Probability of gold and this over probability of this as enter. So meaning that the 101 is here, gold and this range, 101 over 661. Okay, so this is about what this one is all about. Okay, so this is on the aspect of this conditional probability. So it's 101 over 661. Then we divide by probability of this interval of 61 to 60, which is 198 over 61. So the probability is 0.251. So this is it, the probability that we have from here. So this is a conditional probability because they are saying what's the probability that a random selected account 31 to 60 days overdue is a gold card. So gold is here, given that it is 31 to 60. Okay. So this is what goes on. Then the other one is a probability that random selected gold card account is 61 to 90. 61 to 90. Okay. So we are simply saying this interval given that it's gold. 61 to 90 given that it's gold. So it's 61 and gold. So it's 61 and gold. So 61 and gold is 49 over 661 over probability of gold. Probability of gold is 282 over 661. So this is it. How this one came in as 0.174. So 0.174, that's the probability of this one. Then determine whether these events are independent. So the platinum, so determine whether 31 and 60 and platinum, 31 and 60 and platinum, 31 to 60 and the platinum, if they are independent. So for the platinum is 95 over 661. So platinum is 95 over 661. So probability of here we have that 160 given at platinum you are getting the 0.105. Okay, so here the probability that random sector account is between 31 and 60 dues over is 0.3. So these ones are not equalizing the probability. This one and this probability is not equalizing. So meaning that these events are not independent, because for independent events, we simply say testing for independent events. So when you're carrying out a testing, okay, for independent, we simply say probability of A intersection B is equal to probability of A multiplied by probability of B. Then the other aspect is where we say probability of B given A is equal to probability of B if events are independent. Then also probability of A given B is equal to probability of A if events are independent. So this is about carrying out the testing for independent events. Okay. So this is what goes on as we are looking at these events that are independent. Now, of course, we also now look at the other aspect where we look at the normal distribution. So this is our topic for today, the cardinal one that we need to look at, where we are simply saying the features of normal distribution. Okay, so under this, the features of this distribution, we simply look at the bell-shaped and symmetrical area under the shape equal to 1. Then, of course, we also has the range of the values from -3 to +3. These are the ranges of values for this kind of Z value. So this is on what goes on as we are looking at this kind of, and then it uses this formula. All right, so Z calculated is equal to X minus mu over standard deviation, X minus mu over the standard deviation. This is on this kind of normal distribution that we are actually looking at. Okay. Then the other aspect is where now, so we can just get into an example on the normal distribution. Okay, so under a normal distribution, we we consider the standard deviation and the mean. Those two, they are given. As we look at that distribution, so we have the mean and the standard deviation that are given. So under probability distribution, that is what we will look at. Anyway, for the sake of the tables are not here, so we can also switch to I need the tables. I think. Okay, so just a recap on the normal distribution as we are just looking at the questions. So the features of the normal distribution, we are talking about the bell curves and z-scores, identifying the three features of the normal probability distribution. So normal probability distribution is a bell-shaped continuous distribution that fulfills the following conditions. The distribution is symmetrical around the mean, median, and mode are the same value. The total area under the curve equal to 1. The shape of the normal probability distribution is shown below. So we have the mean here. And then because the normal distribution is continuous, it represents infinite main possible values depending on the level of precision. So now the most important thing to understand also is that this one uses the z-score, which is equal to x minus the mean over standard deviation. So this is on the aspect of the normal distribution. Okay, so this is about what goes on. And then we also describe the role that the mean, standard deviation, and the z-score play in the normal probability distribution. The mean is the center of the normal distribution. The higher the mean shifts. So we have this z-score where it is calculated is what x minus mu over standard deviation. This is on the z-score value that we actually consider as we are looking at this kind of equation. And then we can have an example here that we are going to have a z-score value for x, where the mean and standard deviation is into the z-score formula. So we create the probability that, so we have refer to the speeds. Okay, so like an example here, refer to the speeds at which cars pass through a checkpoint. Assume that the speed are normal distributed, such as the mu is 61, standard deviation is 4. Calculate the probability that the next car that passes through the checkpoint will be traveling slower than 65. So probability that x is less than 65. So you're going to say the calculated is equal to x minus the mu over the standard deviation. So this is about what goes on as we are looking at the normal distribution. So we substitute in this equation. So z calculated x minus mu over standard deviation, 65 minus 61 over 4. And then we are simply saying our z calculated is equal to 1. So probability that, so here you're simply saying now probability that the Z calculated is less than 1. So we come here and say probability that Z calculated is less than 1. So you have to come and just do this. You locate a 1 here. So Z less than 1, we are simply going for these values. This is about what goes on. So meaning we are going to say the 0.5 that we could have shaded, which is this one, is 0.5. Then plus a probability of 1, which is 0.3413, which we can get from the table. This one is getting from the table. So the table, we are simply looking at for 1 is 0.3413, which is this one. So this is where you are getting your probability less than 1 is 0.8413. That we could have actually gotten 0.8413. So this is about the probability that we have actually gotten. All right. So this is on this aspect of probability that we have.
Excuse me, Mr. Stanley.
Yes.
So this one that we've calculated, we have to standardize it.
Yes. We are supposed to standardize.
So meaning the one that's 0.3413 from the Z table.
Yes.
Then we add it to the other half, the 0.51.
Yeah, so this whole lot is 0.5, then plus the probability for this one here. Probability for this area.
Oh, I see. Okay.
So probability from here up to here is a 0.3413. So this is on this one, then plus the 0.5, that is coming to 0.8413. So this is what goes on.
Thank you.
Okay, so who can give me the answer when we say probability?
I also have a question.
Probability.
Sorry.
Uh-huh.
Yes, it's in relation to what our friend was asking. But for me, I wanted to get a clarification on how to get the 0.3413 on the Z-score table.
Okay.
Yes, thank you.
So on the table, when you find these are Z values, these are Z values. So when you say Z1, it's the same as 1.0. 1.0, so 0.34, this is the way it is here. If it is Z 1.02, you get this as 1.02 is this 1.02, and 1.03 is that value for Z that we can get from there. Okay.
Okay, thank you.
So if you are to find the probability that For example, we find probability that Z calculated is less 1.05. So we have to locate where 1.05 is. Okay, so 1.05, you locate it on this one, 1.05. So Z less 1.05, it is this whole area, okay, that you need to get. So what have you done? You find that you would have shaded. The answer would have been, we have shaded the 0.5. So 0.5, then plus 1.05, you locate for this one now. This one you get from the table for 1.05. So for this area here, you need to go and locate the 1.05. So 1.05, 1.05, it is 0.3531. 0.3531. So it will be 0.3531. So we can add these two and get the answer. Okay. The 0.5 plus 0.3531. So the answer is 0.8, 0.8531. This is what we have, and this is about what needs to be done on this one. Okay. Are we together? Are you with me?
Yes, we are.
Okay, who can give me the answer for probability of when you get Z calculated greater than 1? So you have to locate 1. So you put a 1 somewhere. So Z calculated greater than 1. So you put a 1 here. So Z calculated greater than 1. This is the probability we are looking at. So it's here. So meaning what we are going to have is, so this probability that we are looking for here. Okay, so the answer will be 0.5. We are getting this 0.5 from this other side with bell shape. So total probability from here up to here. So 0.5 minus 0.3413. So we can now sort out that one. So 0.5 minus 0.3413. So the answer will give us 0.1587. 0.1587. So that is the answer, 0.1587. So this is it on what we have. Okay. Okay, so this is about, we know how to, this is what is important, because you need to know when you need to subtract and when you need to add. Okay, for this kind of problem. So you need to know when to subtract and when to add. All right, so this is about what this one goes in for. Okay, so you need to know when to subtract and when to add. Okay, so that is about finding out the probability on the normal distribution. Okay, so the tables are here. I want somebody to explain to me or find out the answer for me, especially when we have the Z value, an example, probability that Z calculated, probability that Z calculated, Z is less 0.75. Probability that Z calculated is less 0.75. So you look at 0.75 here. Okay, so 0.75 is on this side. Then probability that Z is less this. So we are talking about shading this area. So the area with the shading will actually tell us the value of probability if it will be less or greater than a certain value. So it will be 0.5, then plus the probability of 0.75. So the 0.75, you check it from the table there to give us what we need. So 0.75, 0.7, and 5 is 0.2734. 0.2734. So 0.7 and 5. So it's giving us this 0.2734. So 0.2734. So we are going to have our probability will be 0.5 plus 0.2734. So it's giving us 0.7734. Are we together here?
Yes.
Okay, so who can give us the answer when we are saying probability that Z calculated is greater -1, okay, greater than -1. So you have to locate where -1 is. So greater than -1, you come this side and put -1 here. So anything greater than -1, we are simply shading this area. Okay, so meaning that it will be the 0.5 that you have shaded for this one. So 0.5, then plus the probability of this area here. So the probability of this area, the probability of that area here, this one is 0.3413. So it will give us 0.8413. 0.8413. So this is on this kind of probability. All right. So this is how we go about this one, please. So there's nothing more on this one that it's not a complicated kind of topic. So this is how you are getting the shading. Okay, so probability that Z, so probability that Z is actually less than 1. You have to locate the 1 So you're getting all this area. That's the probability that 0.8413 that we are getting. Then when we have the mean of 61 and the standard deviation of 4, so we can find the probability of more than 6 miles. So you substitute in this one, get the Z of 1.25. So the probability that Z is actually greater than 1.25. So greater 1.25, you locate 1.25 somewhere. So probability that Z is greater 1.25. So you indicate the 1.25. Okay, so 1.25 is this area that you are looking for. So it will definitely be 0.5 minus the probability of 1.25 from the table. So from the table, 1.25, you get 1.2 and 5. Okay. So 1.25. Of course, this can be a cumulative table. So 1.25, 1.25. So we have this 1.25. See this one. So these are cumulative. So meaning that there is the 0.5 that is incorporated in this one. So subtract it. So the normal one without cumulative, it will give us 0.3944. Okay, 0.39. So meaning 0.3944. So the probability from here to here is 0.3944. So it's 0.5 minus that. So the answer here is 0.1056. Okay. So these tables here, they are cumulative. So you need to subtract. For the normal tables, you need to subtract the 0.5 from each of these values here. So we are simply saying our value for this one is can you even go for this other one? For this other one, we get the Z-score for X of 59. So we are simply saying X minus mu over standard deviation. So 59 minus 61 over standard deviation of 4. I already calculated the negative 0.5. So we calculate the negative 0.5 is here. So it will be probability that Z is less negative 0.5. So it will be, we draw this gap. So negative 0.5 is here. So Z that is less than this is this value. So it will be equal to 0.5 minus the probability of 0.5. So we can take from the table here, the Z is 0.5, 0.50, 0.1915, 0.1915. Here, so negative 0.5. So it will be here, you simply say probability that Z is less negative 0.5 is equal to this whole area is 0.5, so 0.5 minus the probability of 0.1915, 0.1915. So we can find the value there. 0.5 minus 0.1915. So it's 0.3, 0.3085. 0.3085. This is a probability that Z is less negative 0.5. So this is about what this distribution is about. So here we have the mean of square 1 and the standard deviation of 4. So it's just a matter of substituting here and probability of more than 58 miles. So you get the Z value. So by substituting here is negative. So it will be probability that Z is greater negative 0.75. So this we can locate. So probability of that. So negative 0.75, negative 0.75 is this kind of area that we are interested in. So this is about what distribution. So it will show us. So 0.75, we have shaded the 0.5 plus what is here. We can get this one from the table. So negative 0.75 from here to here. 0.75, Z negative 0.75. We get it from the table here. Negative 0.75, 0.2734. 0.2734. 0.2734 plus 0.5. So this one will give us the 0.2734 plus 0.5 with 0.77, 0.7734. So this is the probability that we have here. So this is about what goes on as we are looking at these probability types. So it is just about these basic principles that we use to go for these probabilities. So unless there are more questions, but so you will try these other questions as an example now in your own time that we need to come and discuss the next class for these other ones that we have here that we need to look at and we come and discuss them. So this will be shared so that you go through this. Where you have issues on how to get these, locate this one from the tables, we'll be able to come and understand and go through together. Is that all right?
Yeah, cool.
Okay, thank you. So these ones will be shared. So go through this other material that where you have issues, you'll be able to come and discuss together again for some of these questions coming down on this one. So we can name the class for now. So the concept is what is important. Okay, looking at where you are shading on the bell shape.
Okay, thanks.
Okay.